Guys, it's been long since my last video. Okay, so so on this series I will we will try to work with Firebase. So we're going to see how to use a couple of their services to on our app. So for those who don't know anything about Firebase, let me see. I can try if they can come up with good. So mostly Firebase is just how do they call it? It's a SaaS. It's they say SaaS. I want to know the good definition of SaaS. If they can give me what is SaaS. Software as a service, cloud-based model delivering application to use over the internet. Okay, so no worries. So what Firebase is? It's a service that they mostly they handle heavy tasks of dealing with your data. Okay, so when you want to create a system, or you want to create a software, you have to most things you have to interact with a database. You have to configure servers, and then developing specific APIs for specific needs. Okay, so Firebase is just a SaaS, or if it's a platform, if it's a good say for it, that they handle for you that all those stuffs. They have services for authentication, meaning that it's easy to integrate, sign in, sign up, and also other third parties like Google, Apple, Facebook. They have data storage services. That means you don't have to configure anything. You just enable that service, and then you can store all your information. They have even for file storage if you want to store images. So they help us in making sure we can develop a software very quick. And Firebase is mostly used for prototyping, of course, because you don't have a lot of hassles to come up with your product, APIs, all of that, which you will usually do if you don't use Firebase. You have to develop APIs. You have to find a specific server where you will host those APIs or deploy, and then you have to handle even those some kind of configurations, environment, all of that stuff. So it's a bit complicated at first. So that's why most people now use Firebase, because they handle a lot of stuff. So you just have to say what data you want to store. You just define it on any um, language or okay, framework you are using to develop a particular system. Okay, so we're going to try and use most of the services, and you can see how it helps us to come up with good app with a lot of functionalities without the hassle of doing a lot of stuff on your own. Okay, so what I've done to save time is I just create a Flutter project. I just call it userly. Okay, so what we need now to do is to see how do we connect Flutter and Firebase. Okay, so before continuing, this is for not beginner level. You have to know a bit of how Flutter works and all that stuff, but for Firebase you don't have to know anything. We will try our best to do everything from scratch and see how it works. Okay, so just create a project, name anything you want to name. If you're using the terminal, you can just say Flutter create. And I think you can also for Android, they have a graphical interface to create a project. Okay, so okay, as usual, I'm a fan of clean architecture, so I try my best to make sure my project is well organized. So it helps, of course, to understand how professional apps are being built, but also it helps you a lot later on to add more features without any complication. It helps for scalability purpose. Okay, so I didn't want to go through what on all of this, But usually what I do is I create a source folder, and then inside there will be a core. So core, we will put all of the necessary things that you see, we see like it is needed on the entire app. The entire app will share it. Okay, so common mostly is widgets. So any reusable widget that you think they will be used all over the app, we put it here, and in whatever buttons, text field, anything. Okay, so this is for that, and I've already added them, so to save time, because this is not a beginner friend video for most of the CUI and Flutter basic stuffs. Okay, so constant is where we will use Firebase to call our, we will see later on. Okay, and D here we're going to see what is this dependency injection. Okay, so we define it here, and then the use cases is just an abstract class that how we're going to define use cases. You will see what are use cases, of course, because it's mostly used when we are using clean architecture. And I think, I don't know what it is. I think I wanted to add something, but it's okay. Okay, and then we are going on feature first. Okay, so there's a couple of there's a video which explain a lot on these stuffs, so you can go back and take a look of it. Unfortunately, it's in Swahili version, so I think I will have to find a way to make sure it, even for people who don't know Swahili can understand. Okay, so what is feature first? Feature first, we just put a certain or a specific feature on its own folder. Okay, so if we are dealing with authentication, meaning sign up and signing, we are going to create its own folder, and all of the necessary things that are needed for that feature to work will be inside that specific folder. So things like what? Things like UIs, you see, things like state management, things like dealing with external data source. Okay, so if you're using APIs, if you're using Firebase, for example, here we're going to see all of those things will be stayed inside a specific feature. Okay, inside a specific folder. And the good part of that is it helps us to, it's more of managing stuffs. It helps to manage, even if you have 100 features, you know, when we have an issue, you know which feature to go to, and troubleshoot that specific bug. Okay, so for us, we're not going to deal with authentication right now. We're going to, on this first couple of videos, we're going to see how to interact with Firebase and when it comes to handling data. So we're going to see how to store, how to update, how to delete a specific document, and also how to read a specific document. Okay, so for now we can just call, feature. We say, let's, for example, we want to try to say, we are dealing with users. Okay, so there's an extension for those who are using VS Code. Is called, if I can see, I think this one, if I'm not, Flutter Clean Architecture, feature scaffolding. So I think this is the one. So what it does, it creates for you a specific, all the necessary folders that are needed for you to define that feature. So in clean architecture, we know there are layers that are needed when you're saying I'm implementing clean architecture. Okay, so I think this extension gives us these kind of things. Not this block new, no, this is for block, I think, but this is for a specific feature. So we can say user. Okay, so you see what it has done. Okay, so what is it has done here, and say, let's say later on we will need authentication. Okay, authentication. Okay, so you see, so It's just an extension that help us to generate all these folders. It's just to speed up your product, your development. Okay, so it created for us 3 layers. Okay, so these are layers when you're dealing with clean architecture. Okay, so all of I can explain a lot, but the purpose of clean architecture is just to separate concern for a different task. Okay, so when you're saying presentation layer, this is where we're going to define all our UIs, all of our state management. Whatever you're using, provider you're using, Riverpod, you're using Block, we are going to define it, all of them here for that specific feature. Okay, so here are UIs, widgets, and all of necessary user interface stuffs that the user will interact and see. Domain is where we define our interfaces. Okay, so interfaces means like an abstract classes that define or guide on that specific feature. What do we need to do? The business logic stuffs. Okay, and the data layer, this is where we're going to interact with a external data source or external sources. Okay, so here we're going to deal with fetching if there's the need for fetching. Here we're going to deal with for our example, Firebase. So here we're going to deal with all necessary implementation that are needed for us to interact with Firebase. Okay, so you can see it's just to this help us just to manage all of necessary things that when you're dealing with implementing a certain feature. We can avoid this, and mostly this is not necessary for a small app, but it is good if you are planning to or see that app can grow more and a lot of features can be inside that. So we're going to see, and we will walk through together step by step. And also, if it's not you cannot understand the first time, you can come later on and review it and change a couple of things. I think that's how you learn to do it, to work with or to implement this kind of software development stuff. So you have to learn and then try yourself to change and see how it works. Okay. So now we define our layers, 3 layers, and then so what we need now is the first step is to go to the domain layer and define our business logical. What are the requirements that are needed to be able to implement this crowd operation? Meaning we're going to deal with create, we're going to see read, update, and also delete. So let's go to the domain layer and see what are the things that are needed on the domain layer. So I rushed a bit. So before we do all those necessary things needed to implement those features, let's connect our project with Firebase. Okay, so nowadays they have something called Flutter Fire, meaning you can connect your Flutter project with the specific Firebase with Firebase, just using the command line. Back then you were supposed to have to do that manually, meaning for Flutter, go to iOS and add those necessary things that will instruct you, and then go to Android and then do that, go to web, do that. So but for nowadays you don't have to do that if you're using Flutterfire. Okay, so I think this is you go to this documentation and then you can see how they explain it. Very simple. Just have to have node on your system to use npm to install, I think, Firebase. I think, yeah. So just go to this and then it's very straightforward. Okay, I've already done it, and then the Flutterfire is already installed. Okay, so what I want to do now first is I just want to create that project. You would need to go to Firebase console, log in to the specific to your specific Google account, and then go to Firebase console. Okay, and then create a project that you need. Okay, name it whatever you need. I think I can call it userly. Should I add up? Okay, just call it userly. What I think. Let's leave it there that way. Enable Google Analytics. Yeah, just leave it as it is. Select an account, default account, create project. Okay. Okay, so just wait for the Firebase to create a project. Your Firebase project is ready. Continue. Okay. And okay, we are already inside. I think it's dark mode because there's an extension I configured. Okay, so iOS, Android, Web, Flutter. Okay, so now what we need is to connect this usually to our Flutter project, so we can interact with the services we can interact with Firebase services for this specific project. Okay, so I usually go to my terminal and I run this because I'm having issues. Flutter command is not found or is not recognized. So this is another solution just to ensure that Flutter's Flyer CLI is working. Okay, so what it will do, it will fetch. First, before this, you have to log in to that to Firebase. Once you install Firebase, you have to log in, and then for that specific account, and then it will, when you hit this command, it will fetch all the project that you created for that specific account. Okay, so what we need, what it did, it fetch all of the projects that are available on our account in Firebase. We created userly, so this is the one we need. We call it, and then it asks which platform should your configuration support. Okay, so I need iOS, I need Android. If you don't need macOS, use, I think, Inter to remove it. Web. Okay, let's just leave web. Maybe we may need it later. And then which product, then after that, Inter. Which Android application you want to use for this. Which Android application ID or package name. So what you will get, this you will get it on, I think, on build Ghetto. Okay, so build Ghetto under app. Okay, so you copy this com.userly app. Okay, this one. Oh no, application ID, this one. I think it's the same. No, it's this one that you need. Application ID. Yeah, but it's the same. No need com.example.userly. Okay, so this is what you will need to put it here. So hit enter. So what they're doing here, they're configuring all necessary things that is needed for Firebase to able to interact with this Flutter project. Okay, so usually back then you have to do all those stuffs, but it was not that hard. But this simplifies a lot. Okay, so let's wait. Okay, they're saying Firebase configuration file, Firebase option generated successful with the Firebase apps. So the meaning this everything is well connected. The last thing we need to do is add this package. I think this is the only package we need for now. Cloud Firestore. We're going to use Cloud Firestore to interact with storing those document. Firebase Core. Get it for dependency injection. We're going to use block for state management. We're going to use equatable for equalities, UID to generate IDs, and freeze. We're going to use a lot of code generation to speed up the development. I'm a fan of it, but so you can see how I develop quickly specific features with the help of code generation. Okay, so lastly, before after installing all this, we need to make sure there is widget ensure initialized, and then we're going to await. What we need here is to call the Firebase initialize up, and then sync. Okay, so Firebase we're going to import initialize up. I think I installed Firebase. Maybe I just need to. I think I installed Firebase core. Okay, so maybe just run it again and see. So as you can see, it's very easy with the use of Flutter CLI, Flutter Fire. Okay, we instruct them what we need. They ask a couple of things, package ID, we're done. Okay, so now Firebase core. Okay, so this is needed to ensure that Firebase is initialized on this app. Okay, so we can in order for us to be able to use all of the necessary services that we're going to see how we interact with them on this series. Okay, so this is good. I think we have already connected our project with Firebase, and what we need is we need to, once you connect a project, your Flutter project with Firebase, you need to go to Firebase dashboard or console, and you need to enable a couple of services that you're going to need. Okay, so these are a couple of services that they have. They have analytics section where they have build section there. I think they have run where there's also those kind of stuff, messaging, all the stuff. So remote config, crash analytics. Okay, so we need to enable a couple of services that we think we're going to need for now. Okay, so there's authentication, we're going to need it. I think there's also Firestore database, and then later on storage we're going to see as it. So let's enable this, and then I will see and show you how do you enable it, and then how you're going to back to your Flutter project and interact with it. Okay, so I'm going to enable a couple of services. The first one is authentication. Okay, authenticate and manage users from priorities of provider without server-side code. So this is why most of people opt for Firebase. You don't have to go all these hassles. And this is this native providers, additional providers. We can say enable, save. We're going to see how to work with email and password. I think that is it for now. Okay, let's go to Firestore database. Real-time updates, powerful queries, and automatic scaling. So this is good. There's real-time updates, which is very good, and it's very complicated, complex thing if you are doing on your own on our servers. Okay, you have to use a couple of stuffs. But for Firebase, they handle for you real-time updates. So once you update something or you delete something or you change something on there, you will see that instantly it shows on your platform, on your app, which is very hard to implement that if you're using normal APIs, maybe if you're using Node or Python or Laravel or PHP. Okay, so it's all of those, they are still achievable. You can still achieve real time, but there's a couple of extra steps you have to go through. Okay, so we have to just create a database. Database ID, location. I usually don't know which one is close to me, but let's leave it to default. To the default one. Your data is private by default. Client reader will only be granted as specific. What is this? So normally when you say you start in test mode, the default rules allow anyone with difference to view and data. I don't know. I think for test mode is that they will delete after 30 days. Okay, let's just start in test mode. This. Okay. Okay, so okay, so now it's done. So we're going to see how to interact with Firestore. So here there's rules, there's indexes, mostly I think scenarios we will need. But for our project, we're going to keep things very simple. Rules here, you can just define even authenticated user to read data, all the stuff. Okay, so for now it's open. So this is done. Let's go back to our project. We have enabled this. We're going to continue to enable other stuff later on this series. But for now, this is all we need, especially Cloud Firestore. Okay, so we go back to our project. Okay, and also remember to add these packages for so we're going to use them. Okay, so we're done connecting with our Flutter with the Firebase, and then you go to domain, and then here we will need to define our entities, repositories, and also use cases. Okay, so domain, as I explained earlier, that this is where we will defining interfaces for this feature user. What are the things that we need to implement? Okay, so entities is just like an object. Okay, an object where we will define I think attributes or that are needed for a user. When you say user, what are the things that he needs, or what are the things that are included when you are defining a user as a model, or as an object. Okay, so we're going to call user entity file. Okay, and then so normally what what an entity is, what the business requirement says, what user contain of what things. Okay, so this mostly, if you're using normal APIs, you will have to see that API, the database, what are they returning for you, and then from there you can be able to define an entity of that for that particular. Okay, so equitable. Equitable is we're using for equalities, and equalities meaning it has to differentiate one class with another. Normally, if without equitable, you have to go a long process just to do that. Okay, so there is don't need a butter. We may need it, but let's not. We need not password. We're going to add them. Oh, let's just add them, and then we will I think final first string, first name, and then I say I think we guess we're gonna need last name, and I think is generate constructor. So generate constructor, I think it's an extension. I don't know how it calls, and that comes with those method. I don't know what it is. I don't know what's the name, but I will. Okay, so this just let's make them nullable. I usually don't like required because things can become null. Okay. What do you think a user could need? In a very simple scenario, we need ID, name, email, password, first name, last name, and also we need timestamp, maybe saying that's coming from cloud created at, when was the user created at. Okay, and then I think that's all we need. Okay, so okay, I think that's all we need, and then maybe just add this dot created at. So okay, so what we're doing here, we're just defining an entity for this specific feature, which is user, and then we're defining what are the necessary things that are needed for user. So normally, as I said, this is something that you'll have to see from the database if you are dealing, if there's a specific person doing the backend. But because we're using Firebase, we can define it right here, and then Firebase will handle the storing of that user. Okay. And then for equalities, what we need here is just passing an ID. That's all, because the ID it's unique. That's all we need for equitable to be able to differentiate different classes. So we will see why, because there's going to be a scenario where we're going to list all of the users, so we have to give we have to be able to differentiate one user from another, one class from another class. So we are using equitable for mostly that purpose. And I think this is that's all we need. The next step, when you're dealing with clean architecture, you define an entity, and then you go to define a repository, meaning what are the methods that you need to be able to implement this specific feature based on your business requirement. Okay, so git.keep, I don't know, what is it? Okay, so now let's go to user repository. We define our method, and then we go to the use cases. Use cases I'm going to explain to you in a very simple way so you understand. Okay, so let's go back and continue. So now let's go and define the repository abstract classes. Okay, so we're going to call it user repository. repository got that. Okay, so here we're just we are still inside the domain layer. Okay, so we're dealing mostly with abstract classes. Okay, what abstract classes? The abstract classes, the purpose of defining this is that we are hiding away, we're hiding the implementation of this creating user. For example, it's going to be done in the data layer, and we are giving the flexibility in code reusability, because you can extend this class on any class subclasses that need this method. Okay, so we are giving hiding an implementation because we don't care what we're going to use to create a user. I'm going to store that on the Firebase. I'm going to store on the APIs. I'm going to store on Superbase. I'm going to store that on local storage, meaning maybe if you're using SQLite or Hive, whatever. So those specific functionality and implementation, they can be done on other subclasses, but here we're just defining an interface of what we need. Okay, so that's why we define mostly abstract classes, and then other subclasses they can extend and do the specific implementation. Okay, so if you will need later on a user repository, but on another one of the method on the user repository, but is on another subclass, you just extend this, and then you will get all of this method, and then you can implement a specific functionality, or you can deal with external sources the way you want, according to what you'll be instructed to. Okay, so we need create user. Okay, and then let's define two for now, and then also we need to list to Firebase to give us a list of all users. Okay, we can say get all, or just give it get users. Okay, so user model, we are going to deal with it. Okay, on the data layer, because we are going to need a couple of method that are going to fit us or suit us when we are dealing with sending that user to the Firebase. That's why we need that. But this one will still extend the user entity. We will see. Okay. The matter of fact, maybe let's this user model will go to the data layer. Okay, so I'm going to add it. Okay, and we're going to see why we need user model, why not user entity. Okay, so now this is we are defining abstract classes. We've already done that. We are going to define use cases, meaning we are going to define each method its own use case. Create user is going to have its own use case. Get users is going to have its own use case. Why? Separation of concern. Specific every class can handle a specific task. So create user, this is the one that's going to connect us with the UI layer and all and other layers we are going to see. So this create user is the one that's going to connect these other layers and give us the specific information that we need. Okay, so that's why mostly we use these use cases. Okay, as I said, this is not necessary for a small project too, but for bigger project it helps a lot. Okay, so we're going to define a class called create user use case. Okay, and then going to implement use case with params. Okay, I'm going to show you what it does. So we're going to give it user model. Okay, so use case with params. This is just the way we just define the global way of dealing with use case, of using use case. We don't want anyone to come and define their own way of using use cases. That's the whole reason. That's why we put it on the core. Okay, so there is use case with param, use case without params, and all use case without param switcher. So it's just an uniformity, or just so to have okay. So use cases always, they need user repository, they need to interact with user repository. Okay, that's all, because user repository is the one that define create user. I'm using Codium for code generation. I really like it. It's just very simple. That's why you see a lot of code completions. It's good. I think I would see their, do they have premium stuffs? What are they saying? Nice. Okay, so okay, always use cases, you have to understand it needs to interact with user repository, and user repository is the one that defines abstract classes. We are going to see where the implementation will be done, and this use case is going to interact with the UI and the state to give a specific functionality. So it's need an override here. On params, we're going to expect user model. Okay, so params, we are going to see how it works, but once you got a hang of, or you are comfortable with this, you're going to really enjoy using clean architecture. Okay, so use case need params, pass it. We didn't define user model, we're going to define it, then we're going to import. Okay, so now we create a use case, because that's the first thing we're going to do. We're going to implement the functionality of taking information from our app and then saving that information to Firebase. Okay, so we're going to see, and I'm going to explain again the whole process slowly, so you get a bit of an understanding. Okay, so mostly for domain layer, once we deal with this user entity defining or whatever the entity you'll be dealing with, and then we go to user repository defining all the method, and then we define use case. Okay, use case, and then we're going to see how this user model, why do we need user model, not user entity. Okay, so the next step after dealing with this, we are going to data layer, and in data layer they have already added for us this data extension I showed you, the data source. This is where we interact with the database. For our case is Firebase models. This is where we will take those kind of information that are coming from the external source and manipulating them and putting them in a way that understand, and they can and provide it to us. And repository, here we are going to deal with that implementation of the repository that we define here in abstract class. Here we're going to deal with the implementation, specific implementation. So we are going slowly, and we are going to see. So I want to define that user model, sorry, and I'm going to explain to you, okay, what is it and why is it necessary. So okay, so we had an issue with user model. It was not defined, so I already had it. I'm going to explain to you. Okay, so abstract class, we need a user model param also on the use case. we need a user model. Okay, so what, oh, what was the need to add user model? So as you can see, user model extend user entity. Okay, so mostly the scenarios here happens when user entity may be too large. Okay, you have to define it, of course, but when you come to specific feature, maybe there are a couple of things you only need from user entity. I mean, okay, so you don't have to return an entire user entity. Okay, so mostly we use is maybe on the certain API, the response that is coming back from the server, it does a lot of things. Okay, but we need a small a couple of things, not all the entire entity, because it may be too large, maybe if it's a big application. Okay, so we will need a couple of, maybe for displaying or for listing users according to the design or the interface or the UI. The only thing, maybe there is a need of a name, last name, when was the user created. That's all. Okay, so we don't need to return an entire entity. So here, user model is where we will manipulate those data that are coming from external source, so that can be able to understand and give that kind of information to the interface. Okay, so because we are using Firebase, there's a couple of methods we just need, because we are going to read information from the Firebase and send that information, specific information, to the Firebase. When we are creating, we are sending that kind of information that we've taken, that we've retrieved from our input on a mobile app, maybe. And when we are reading those information, we are reading that kind of information directly from the Firebase. So here there's, as you can see here, there's method that are only needed here. The first one is from snapshot, and then another one is to document. Okay, from snapshot, this is coming from Cloud Firestore. It helps us to read this document, because Firebase is all about document. We are dealing with document, that's all. Okay, so there's no table. It's a NoSQL, so there's no tables like other database. There's only interacting with document. Okay, document. So document snapshot, this is coming from Cloud Firestore. It helps us to retrieve those data from snapshot of data, and then we can manipulate and take those data, and then this help us to understand this and be able to show those information. Okay, and to document, this is when we are creating or sending specific information to the Firebase. This is a method that we use mostly just for clean. We are going to see why. For just clean code, just try to make sure everything is well organized. These are the information that we'll take from the user input. Okay, maybe text form field, we're going to see, and then we're going to send those to Firebase. That's why we needed user model. Okay, but it still extends user entity. Okay, that's it. So user model, it only helps us to create methods that are necessary to interact with a specific external source, but we will need all of the information coming to the user entity. We don't have to hide something that is not available to the entity. Okay, so so if we say okay, I want to explain something here, but okay, so now let's move on to data source. This is where we're going to do all the heavy implementation of interacting with the Firebase. So we're going to see what are the things that are needed from the data source, how do we interact with Firebase heavily, okay, because what we'd have done, we've only deal with defining interfaces and all that. So we're going to see how to works now with Firebase and deal with all of necessary implementation that we need for this project. As we said, for now we're starting with CRUD, meaning we're going to learn how to store, how to delete, how to read, and how to update using with Firebase. Okay, using Cloud Firestore as our database. Okay, so let's continue. Now we're still in the data layer. Okay, so we are moving to data source, and this is where we will deal with dealing with external sources, meaning we will do those implementation to implement a certain feature. Okay, so right now in data source we will define two folders. Okay, first one will be user remote source. It means here we will work on fetching and retrieving and sending information or documents to a particular API, or if it's Firebase to store the data on the inside the user Firebase our Firebase project. Okay, so we will need to define as usual abstract classes. As I explained, it help us to it's mainly it's for code usability, meaning we can use this interface, okay, even on varieties of classes, okay, instead of writing it again all over again. So what we need to do here, we can define two methods for now. First one is we can create can define a method to send information and store that on database, but also we can retrieve a list of all users. Okay, so we are using stream. We can use future, of course. If mostly future you use if you're using APIs, meaning data coming from the server. Mostly they are future. Okay, so you need to wait until the entire call will be executed. But we use stream because the benefit of using Firestore, Cloud Firestore, we have real-time capabilities to deal with our document. Okay, so we can get that information in real time, meaning if if we are sending that information, maybe or storing that information to the database, for our scenario is Firestore. It means we have real-time capabilities of also listening if there's any data that has been added to our database. Okay, so that's why we use stream. That's the benefit of it. Okay, so we need to add one more class. Okay, say user remote source. Okay, so this is mainly this how it's like a pattern. Mostly once you implement one feature, everything kind of the pattern's always the same. Okay, so we will add one file, data source, user remote data source implementation. Okay, so here we will implement those the method that we've defined on these abstract classes. Okay, so we can call class user remote data source implementation. That's why I love Codium to help to speed up. Okay. Okay. Okay, so we extend user remote okay, missing concrete implementation. Yeah, because we extend user remote data source, it will need us to override, meaning we have to work to add this method. Okay, so this is a good, that's why I mentioned this is a benefit of using abstract classes, meaning as you can see here, we they are giving us all that method that has already been defined, so we have to know this. It will need to accept a parameter of user model, and also this will also stream or listen to a list of user models. So this is a good thing to use abstract classes. They help you to reuse the same method across different subclasses when you want to implement a certain feature. Okay, so uh, on user remote source implementation, we are required to Firebase Firestore. We need Cloud Firestore. So even if you didn't add this package, you can go and add it. Okay, so they're saying, you can see Codium is giving me some completion, but uh, we will use another way, meaning we will require this help us the way of defining this help us in testing, because this create user will need Firestore implementation, Firestore Firebase Firestore package in order to ensure that this method it will work. So this is a good way, because it helps us to, this code is testable. Okay, when we need to test, we will have no difficulties testing the entire method that inside this class. Okay, so the first thing is create user. This is the first that we're going to tackle. Okay, so how do you store information, a particular information, to your database, meaning to your Firebase? So what we need to do is, you will say user collection. You need to define your collection. That, but the benefit of Firebase, you can define it, your collection, right here. We don't need to touch the dashboard. Okay, so Firestore dot collection. Okay, so Firebase, as you know, we added this one, Firebase collection constant. Okay, so this was inside constant. Okay, so Firebase, we call it no, let's say we call it users. Okay, so as more features you add, you just add those collection names here. Okay, so here we say user. What's going on? User. Okay, so you say user, and then we close. And also we need UUID. This is the package we installed already. This helps us to generate random thing we can call random strings. So you say final UID, then you can say UUID version 4. Okay, so because we accept the parameter of user model, so when we are taking this kind of information to our form, okay, when user is filling this, okay, we will call this user model and take and pass all of this information. So we have UID. Okay, so we have UID. Okay, you have username. Username is user, no, not user.username. We have email, user.email. So we are taking this from here, user model. It has that. We have then everything user.email. Okay, we have, what else do we have? First name, last name, created at user to document. Yeah, thank you. So created at, we can use here daytime, but we're going to see when we are using form. So user, when we are taking those kind of information, we will fill that. Okay, so Is everything for now? Yes. Okay, so now what we need to do is to use try and catch to deal with this storing this information. So we have already defined user collection. Okay, so it's a user collection dot doc dot uid. Sorry, user collection dot. Let me stop using um, uid dot get. Okay, and then dot then value can say user doc. Okay, what we need. Okay, so what we're trying to do here is to check if this UID is a user.doc.get. Okay, so this retrieve this information. If we have a document inside Firestore database with the value of this UID. So if not, if user doc, we can say if it doesn't exist, we can say user collection dot doc dot uid dot uid dot set news. Okay, so else okay, else we can just update. Okay, so what we're doing is, if we have that user uid, if it exists, this document with this value of uid which we already generated here, we can update. Okay, if it doesn't exist, then we can say this is how you set, you mean you store. So this is, you can set new user, we already define it here. Okay, so for catch we can say I don't know, we can, because we are still debugging, there's also, we can create another lesson uh, for for dealing with errors. Okay, okay, this is it. Okay, the body calls. Okay, we need to sync. Okay, so because now as you see, we have already this is how you store that kind of, you store information to the Firestore. We define, or we call that name. Okay, so meaning if it's the first time, what will Firestore do? It will create this for you. You don't have to create it, and then it will check all this kind of information, and then we define this to document, which will take all this information and then convert that to document, and then it will say that. Okay, so this is how we create user using Cloud Firestore. Okay, so let's continue. Okay, so we have implement user remote data source implementation. We've worked on how to, we've seen on how to store this information, okay, to our Cloud Firestore. Okay, so you just follow the pattern, and then everything will start to, you know, fill in, and you will understand. So this will come later when we want to implement all users. We are fetching all users, but for now we are dealing with creating users. So what we'll do next, uh, after creating, after dealing with implementation, what you need, the last step, is to go to a repository inside a data layer. Okay, so here you will create a new file called user repository implementation.dart. Okay, so this, it will implement the abstract class that we create on the user repository inside the domain layer. Okay, so as you can see here, we just create this method, and inside user repository implementation we will implement that. How? Let's see. So we will create class user repository implementation, extend user repository. Okay, so I think it's this one. Okay, user repository. Okay, so it's create these are the methods that I was already created, so we need to add them. So now okay, so now we need what class here? So user repository implementation always need user remote data source. Okay, so that's how they connect each other. So you create a user remote data source or whatever feature remote data source, and then you deal with those kind of dealing with external sources, and then user remote user repository implementation will we will uh, connect with the user remote data source and getting those information after you've deal with fetching those kind of information or storing. So whatever you return, user remote repository implementation will deal with that, and then it will connect to use case, and then we'll deal with the state and the UI. So you'll see how this will all connected until you finalize a certain feature. Okay, so now we need user remote data source implementation. I think it is one, if I'm correct. Okay, so you just define it, name, you call that, and as usual, how we define these classes, we always need to call this in a way that are always required, and this help us in dealing with testing. If you don't do this, you're going to have hard time to initialize all the dependencies that you've added on the certain class in order for them to in order for a certain method to work. So you need to require, and then when you're going to do testing, it becomes very easy. You can see my previous video of how I tackle this and do all the testing for different scenarios. Okay, so what we need for create user, always it's we can call like this. Okay, so user remote data source implementation dot create user. We're done. Okay, so after this, okay, so this will create this. We will it will call this. This is a like dependency. So user remote data source will depend on user remote data source implementation. User repository implementation, sorry, will depend on user remote source implementation to be able to execute this create user. Okay, so this is how it is done. Then get user will come later on to deal with it. So after this, you are done with for this create user functionality. Okay, so after we can go to the presentation layer. Okay, and then we can see how do we define this and how do we connect this all of this implementation for our UI in order to execute these functions. Okay, so after dealing with data layer and domain layer, then the last part is working with presentation layer. And in presentation layer, this is where we will deal with UIs and state management for this feature. So this is where you will define your state management solution, whether it's Riverpod, provider, or block, and also UIs, meaning this is where you work with creating those user interface or those UI components for that particular feature that we are working on. So for our case, we're going to use block for state management. Okay, so and then we're going to we are going to also to define the UI, and I didn't focus much on the UI part because this is mainly not for the beginner people. It's not beginner friendly to, so I will most of the UI part I will skip and just show you what I did. Okay, so now what we need to do is we need to define our block. Okay, so because we are using block for state management. Okay, so this the package, the extension that I use to create a feature first it's already added block, but I'm not going to use this one, and I'm going to delete. Okay, so what I will do here is inside I will say create freeze block, because we're going to use code generation, and we're going to utilize a lot of we're going to use freeze package, and also freeze annotation to generate for us a couple of things that are required. Okay, so code generation nowadays, it helps us to speed up, and they will focusing on adding the method that are needed instead of you adding them. You just define, and then they will handle the rest. Okay, so I don't know what is the extension that for this create freeze block, but I will check and I will share with you. So I will create freeze block. It say use, which is a user block. Okay, so it created this, but I want to rename it and call block. Okay, don't want to do. Okay, what is it saying? Yeah. Okay. So what is that? What it has done is it created us a boilerplate for defining our event and state, and also we're going to deal with the execution of those events on our main user block. Okay. So the first thing I always do, I go to state. I go to the state file, and I define this the way I want it. That the way I think it's good, and to manage state. So I usually, for small parts, small things, you can just leave it like this, and then you can continue, but I usually find it hard, especially when you're dealing with 2 or 3 state from the same block in the same screen. So there's a couple of things. If you switch to another state, and then another state will be killed, those kind of scenarios I've been facing. So the way I'm going to define here, it helps a lot when you are in the one screen, and then you want to show different dealing with different state on that screen. It helps to just copy. We're going to use the power of copy with, and then to just change that state if you instructed it to change the particular state and leave other state. But this, it will kill the entire state, and then it will give you. Okay, so without, let's continue. So what we need, first we need to define our enum. This here has user status. This is mostly if you are doing unloading, initialing, initial, we are defining initial, loading success, loading. For now, okay, we can leave this for now. Okay, so what we need to do is inside here, you can see how I create this, and then create user factory. That's good. They given for us a couple of stubs. There's this way, but I usually like to okay, we can leave like this. Okay, so default is going to be that way, and then what else? This is for users, user state. What I usually like to do here, I need a couple of control mouse other part. Of course, this is good, but we will create another tutorial that will utilize a lot of freeze, but I don't want to confuse people here. And then so we will call user status, and then we are going to, what else we need, required, and then we are going to what kind of state we want to manage. And this is wrong. This is, let's say, loaded. What initial, what if user is already let's just call it created. Okay, so it's called created. Okay, so here we will go to, we will use user status, users For now we just need user status because okay, we want to only to work on creating or storing that. So user state dot initial. Okay, so um, okay, user state dot initial. Then we can return const user state user status dot initial. This will be our initial state. Okay, and then okay, user state. Okay, so we will go to block. We will just remove this and then we will go to event. Instead, we're going to run that code that you generated, a couple of things that we need. Okay, so for those who don't know much about block, it's just a state management solution for Flutter. Okay, so what it's doing is it helps you to manage couple of state on your application. So when a user creates this, or when you're going to see how the user will store, we have to notify if the operation was successfully or not. So with that, we will need to check what's the state of that time currently, and then uh, creating that mechanism to notify a user what's happening, what went wrong, and what went good. So block it help us with that. So in block there is mainly event and state. Okay, so you will define an event. You will say, based on this event, do this. If this is not successfully, do this. If this is successfully, so you will see. And state that it's the that's like a symbol that will always be listening. So if it's change, the state will tell you that something has changed. But event, you will only fire that event, and then block will handle that event, and it will give you different state based on the instruction that you tell the block to do. So that's in a very shallow and very simple way. Okay, so now let's define an event. I use code generation a lot because it helps to speed up, but we can find a way to create a blog tutorial for those who are not familiar with it. Okay, so on an event, what we need here is we will need, because we are creating users, so we need factory user event create user model. We don't need user entity. Okay, so it will take this, and then it will give you, you will call this event, you will pass these parameters, okay, or just a parameter that it needs for this event to be fired, and then we will instruct. You will see on block how do we instruct block to deal with that event. Okay, so because we're using code generation, what we need to do is we need to run build run build, and then -d to delete conflict. So this build runner is, I think it's on under dev. I think, where is it? Yeah, so it's this one, and we use freeze to generate for us those important method that are needed. Okay, and then freeze the notation. This is the freeze annotation, the one that we hit inside. It's above this each class. Okay. Okay, so let's wait and see if the operation will be good, so and then we can continue. Okay, user block flows to that must be included as part inside directive. Why you didn't add it yourself? Oh, it's anything that I'm missing here. What do I need? Okay, yeah, I think this package was supposed to add it, not me. Okay, okay, let's do this quickly. Okay, so use as they are saying use a block. Okay, freeze that. Okay, I don't know if that will do a trick. Okay, so let's run it again and then see if it will not throw another error. I think I need to add. I need to add part of. No, 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 no. Something I don't know, but it didn't go as planned. We are supposed to. Let's see. Why it didn't show here? Okay, I think I made a mistake. Something. Okay, and then we had to. I think after because of changing maybe a name. Okay, so you say user. Let's go block and then freeze that. Then okay. Part of user underscore. User block dot freeze dot not underscore dot. Okay, and then here. Okay. What if we delete? I don't know what's happening, but it was supposed to. Let me see. It has to generate that file, not me. Okay, yeah, I remember how it has to generate that file, not me. So we have defined an event, we have defined a state. We will continue to add a couple of that state based on the type of functionality that we are working on. Okay, so in block, this is the part where use cases are supposed to, that's the way they connect with the presentation layer with other layers. Okay, so this is where you will add all the use cases that you've already defined them, okay, on the domain layer. Okay, and as you know, use cases also also depends on the user repository. So, and the user repository implementation also, as you can see, depends on the user remote source implementation. So that's how things are connected and help us to testing and help us to scale the application without any issues, because everything has its own single responsibility. Okay, so with let's do this quickly because we wasted a bit of time here. dealing with. Okay, so create user use case, and then we will need to, as usual, we always require we will need to make sure block need this before work on any of the method that's underneath this class. Okay, so user block, users initial. Okay, so the good thing of block, what we need, okay, okay, let's do this our way. Let's not use this code generation. So first of all, you will need to tell block on what if or after on if a certain event was fired. Okay, you know, this was the event that we call, this is the name on create user. Okay, so you need to say if that event has been called. Okay, what do you need? I usually like to create this on another function, so if it's has a lot of functionality, things can be much cleaner. And then you can say create method. Okay, so let me explain this a bit. We define our event. We've defined our event. Okay, create user. What we need, we pass in a parameter if there are many, because it's one parameter, which is a user model. And then we are going to block and going to instruct it to do something. Okay, so we're going to give block an instruction if that event has been called. Okay, so what's happening, what we're going to need to do is we need to we can just try and catch, if you know. So what we're doing here, we need to say we need to emit first of all, because of just user experience. If it's creating, we need to show some loading indicators, something is happening, and then while we're doing that, storing that information to a Firebase, then we need to show some kind of for loading indicator for just user experience. So we will emit that. We will change the state. That's why I love the way I've defined this state. It helps us to, it will give us the power of copy with. So if we will add more state, then other state will not be affected, because here we're just changing the state of status to user status dot loading, and the other state will be the same. Okay, and then we are calling create user dot call. Okay, this one expect a parameter of user model. We have already passed it where that we are getting from an event, because we know this event, it has passed this parameter also. Okay, so this event we will need, when we are calling this event, we're going to see we will need to pass this parameter, otherwise it will throw and give us some warning that we need to pass it. Okay, so if the event will be called, it will go with this kind of, it will go with those parameters, and then we're going to get them, and then we're going to call create user use case, and then we're going to pass the parameter that it needs. And then if everything goes well, we're going to change the status to status.created. Okay, but if if anything went wrong, we can just call state.copy with. Okay, so we can say status.error. Okay, that's it. So that is very simple, because this scenario here doesn't need a lot of steps. Just send those information, give us whatever has been returned. If an error, if there's anything, then that's all. Okay, so this is how you deal with block and use code generation. Okay, so you need to add freeze, build runner, and then freeze the notation. I don't know this package extension. I'm trying to see if I can get it here. I think if I can, I think something freeze block. I think this one by how. So if you install this extension, you will get this capability. It will help you just create, giving you some boilerplate that you need in order for you to work on this code generation. Okay, so there are many ways of defining your state, but I love to define it in this way. But there are a lot of methods and ways to defining your state and how do you want to manipulate your state. Okay, so this is how I usually do, but I think even freeze has also a couple of state that you can define. Okay, so after this, there's one thing that we need to do before communicating with block and all others, the data layers. What we need to do before going to the UI part, we will need to do some dependency injection. Okay, dependency injection in a simple way, it helps us to inject all the dependencies that are needed for that class to work at the runtime. So when you are calling that class and the method that are inside it, you don't have to initialize again the dependency that you need. Yeah, user block need create user. So whenever you call user block, it will throw an error, and then it will tell you that we need create user use case because it is a required class. It is a required thing that. Okay, so that's why I usually make sure I do some dependency injection. So when I'm running and calling this any method that I want to call on, maybe in block, things have become much easier. Okay, so we're going to use getit here. Okay, so make sure you install getit as I said here. Okay, you're going to install this getit. Okay, and then just go to injection. You can call this class, you can define it whatever, but I usually put it inside core because it's kind of a global thing. Okay, so final locator, okay, dot getit dot instance. Okay, and then why you don't know getit, okay, let's import it manually. Okay, import getit. Okay, now so let's define a function here. So, okay, so let's call it future void, and I will explain to you what are we doing here. Okay, set up locator. Okay, it's in sync. Okay, so we need to define we need to add the classes and all the dependencies that are needed. So what getit will do, it will initialize for you, at runtime. So whenever you need any class, you will just call the class and the method inside it. You don't have to initialize the classes that depend on that class that you're calling. Okay, so final Firestore, we need Firestore, we need to initialize it. So Firebase dot instance. Okay, here. Okay, and then what we're going to do here, we are going to locator, okay, dot register lazy singleton Firestore. Okay, so we already initialize Firestore on the getit. So whenever we're going to use it, like we use it in a user remote source implementation, it will already be there for you. So you don't need to call it and initialize it before using it. Okay, so that's the beauty of getit. Okay, so there are a couple of things also we need to initialize them. So we have use case. Okay, let's call use cases, and then let's call repositories. I think that's and then data sources. Okay, so I will okay, so let's deal with all of this, and then I will explain to you. Why are we doing this? As explained, we just want to get it to work on initializing all of those dependencies that are needed for a certain class, for a particular class, and then we don't have to do any kind of initialization when we need a certain class. We need a method from a certain class. Okay, so we have use case. You can call locator dot register register lazy singleton. You can call this. So you can call create user use case, and then okay, we can okay. So you say create user, and then sorry, I kind of love code completions here from Codium. Okay, so what's happening here? As you can see, create user use case depends on user repository. So whenever we will call this create user use case, it will require us to make sure the user repository is initialized before using the method. Okay, call. So this is the beauty of get it, then that it will do for you here on this function. Then you don't have to worry about create user use case to work when you're calling it. Okay, and the good and another thing, I will explain why we do dependency injection. For now we have one use case, I believe. When we deal with all users, we will add, and then we go to locator.register lazy singleton. We are here, the type is user repository, and then we are we need to use a repository implementation. User repository implementation. Here we need no. Okay, so it's called what? User. Why it require user remote source implementation, I think. User repository implementation. We need to see what do we call user repository? You need to require it. Okay, so on abstract classes, we don't need to do a dependency injection because there is no any kind of method beneath it. So what we need to do is in user repository or any kind of repository or data source implementation, because there's a dependency here, as you can see. So we need to make sure this is available when we call this create user. Okay, and then lastly, let's copy this. So what locator will do, it will check, and then this user repository, what will it do? It will check, okay, and then it will handle the rest. So here we need to call user remote source. I think we call it user remote source, and then here we call it user remote source. I don't know, remote source implementation. Okay. Let's check it. I think we need this one, user remote source implementation. Okay, it requires Firestore, and then Firestore we've already initialized it. Firestore, let's import it so we can, VS Code can know what we need here. Okay, so after this, okay, this is, we will see as we add more uh, uh, dependencies on a certain class, we will see the beauty of dependency injection. Okay, so after this, we will go to, we will need to make sure this is run. Okay, so we will go to main, and then after being under, we will call setup locator. Okay, so what it's going to do, it's going to make sure once when you run this, it will check, and if there I think register resource lazy singleton, I think it will call by saying it will call on first call. So lazy mean I think it will only be called once, only when it's needed. Okay, so for memory leaks and make sure that we don't initialize every time we need it. So that's how we use dependency injection. There are a couple of the other tricks and tips that I think on my previous videos I use a lot dependency injection, so you can see in different scenarios how we tackle injecting those dependency on classes using Gedit. Okay, so this is good for now. Let's go to the UI part and see how do we connect to this and how do we implement this functionality of storing those kind of information to our Firebase. Okay. Before moving on, we need to inject also block with its dependency. Okay, so as you know, block it needs create use case. Okay, create user use case like we define it here. Okay, this method. So we will need also to inject it, and so Gedit can handle the rest. Okay, so what we do, we need to locate a register. It's a factory. Okay, and then the name of that, I think it's user block. Okay, user block. It need create user use case. The locator we will know, so we don't. Okay, so for now, okay, so now as you can see this. Okay, so every time we run our app, Gedit will handle everything for us, and then when we want to use one of these classes, especially maybe let's say user repository or blog, and access other method inside it, there will no there will be no issues of initializing other dependency also. Okay, so this is the most benefit part of using Gedit. Okay, so now if we go, can write it here, user block, okay. Okay, so if we go to main, so this mostly is not for the UI part. I don't want to waste time mostly on UI. Okay, so I've already created this UI. Okay, so this is going to be the first screen once we launch our app. Okay, this will come later to deal with it, to list all the users that are available on our Firebase. Okay, and this is the screen that we're going to deal with sending this information to Firebase, so they can be stored on Cloud Firestore. Okay, so this just define a normal stateful widget. Okay, and also there's a couple of text editing controllers. These are usually mostly when you want mostly for forms when you want to get some information. Okay, so also we dispose these stage controllers because they have listening. I think how you can listen on this text, so they have some listening capabilities, which is bad if you are not on this screen because they will still listen. So we need to dispose to avoid memory leaks. Okay, and a couple of stuffs here. We have an up bar. Okay, so a form, this form key, we have defined it here. This we're going to use for validations. That's the beauty of using form. Once you wrap this with form, you have this form state. So this helps us to do validations for all of our inputs. Okay, so it's a column. Okay, and this is it's a reusable text form field I've defined, so I can to avoid a lot of code. So take a couple of stuffs, takes a controller, hint, validators, and also title and all that. So just a normal text form field. Okay, so we don't have to waste time on that. Key, I usually put it, but I do this one. We do widget testing to have access on this UI. Okay, that's all, and a simple button. This is also a usable button with some parameters, tab, title, color. Okay, simple elevated button. Okay. Okay, so what we need to do right now is to run our app and see the first how the UI look like, and then we're going to do to tackle sending this information to Firebase. Okay, so let's do that. Okay, so we've run our app. I've run it on my device. So you can see this will be the initial screen. This is where we're going to see how to list all the users that are available on our Firebase. But what we need to work on is to when you click this plus, it will go to the page of add users screen. Okay, so you can see as we need just to do a little bit of some padding. Okay, so here we need to go symmetric and then horizontal. Maybe let's give it 10 and see. Let it go 10 just to. Okay, that's okay. That's okay for now. Okay, so what we need to do right now is to submit all of this information that we're getting from this field from this form to Firebase. Okay, so the first thing to do is to just to define a function that will handle this. Okay, so let's just call it submit. Okay, submit. And no, I will do it myself. No need of your. Okay, so what we need to do is to is to take all of this information that are from here, and to submit them to Firebase. Okay, and as we've seen here, we can take this submit. Okay, and then we can put it on this button though. Okay, so this button will be called, this function will be called when we hit this button. Okay, so let's go to the function itself. Okay, so what we need to do is form key dot current state. That's why we use form key. We use form. We have this kind of advantage to validate all the information. So if you can see a field is validator will check if the field is empty. If it is empty, we'll say field is required, field is required, field is required, and all of that. So we assume all the information are needed. Okay. Okay. So what we'll do here, once you hit this submit, it will check based on it will check the state of all forms if everything is according to the given instruction, and then it will continue, or otherwise it will show all those field. Okay. Okay. So if we can try it, if we hit add. Okay, I want to see. Here. Tap submit. Okay. Why is not showing field is required? Okay. Okay, let's do this. Okay, so so we will take all the information. Okay, we will give it a new user. Okay, and then we will use the model to take all the information. So we will have, first thing we have username. We take that from username dot text, and we will have, I think, email. We take from email controller dot text. Okay, so this is how you get the information. It comes it comes on this text field. Okay. Okay, and first name is coming from first name. We'll get that from first name controller dot text. Okay, and then we'll go to, I think the last one is just last name. Last name is we're going to take from last name controller dot text. And what else are we missing here? I think created at. Okay, so created at, we just use timestamp. I think it's coming from Cloud Firestore dot now. Okay. Okay, and let's do this. Else. I'm so easy to wait a minute. Okay, so how do we communicate with block? This is where we get those information, and then we go to send that information to block. Block will take those information and supply that to create use case, because that's where that's the use case that will connect to the repository, and then the repository will handle the rest by submitting and connecting to remote data source. That's when we create those. Okay, so BL off. Okay, so this just, I think when you install block, you have this kind of how do they call them, snippet, I think. Okay, so we will import block itself, and then we will import user block, and then because we have in block we have event, we have state. What we need to do here is to trigger that event, to call that event, and that event expect a parameter of user, as you can see here. Okay, this create user expect this user model. Okay, so how do you do that? You will just say add, and then you call that event create user, and then you supply that new user. Okay, so this is how you deal with sending information, interacting with block, change the state. We're going to see also on the state part, But on the event, this is going where you're going to call that event. Okay, so if that event doesn't expect any parameter, we will see we don't have to supply it. But if it needs, you need to make sure what information it needs. Okay, so what it's going to do here is once you add this event by using add, okay, call that specific block, add the event, pass the required information that it needs, and what it will do, it will come here on create user because we've checked that event if the event is being called. Okay, so this method will be called and it will do all the necessary instructions. Okay, so we are going to say emit, and then we need to change state to user loading, and then we're going to create a user and call. We're going to interact with use case, which is for us is create user use case, and it's also expecting a parameter, okay, of user model, and then we're going to pass it. We're going to, from event, we're going to get that from an event because this is where we've called that. Okay, so and if everything is working fine, it's going to be created. If there's an error or anything, it's going to throw for us an error. The state will handle that. Okay, so this is the first step. So because we need to deal with some user, we need to deal with some user experience. Okay, so we need to show maybe a load indicator to show something that can make a user to know what's going on. Okay, so how we're going to do that? We have already called a block. Okay, this it will be called, but we need to also to interact to do some kind of user experience for our user. So we need to deal with to check the state and also to show a specific maybe a load indicator that something is happening. Maybe please wait. Okay, so let's see that. My voice was a bit low, so I need to do some improvement. Okay, so now we need to deal with okay, so now once if you click this and you click add user, it will show okay all the fields are required. Okay, this is because of the use of this. Okay, current state form key. Okay, so it helps us to do that. Otherwise we'll have to do ourselves manual, which is a bit of a process. Okay, so what we need to do here. Okay, so in block we have something that is called, we have block listeners, we have block consumer, we have a lot of block builders. You can check their documentation, okay, to learn other stuffs. Okay, so what we need to do here, we need to wrap this with we call block consumer, and then we need to say user block and user state. Okay, so what is happening? Why do we use block consumer? So block consumer give us sorry, we need to do something here. We need to do something here. I forgot. Okay, so what we need to do is we need to do something like this. Okay, we need to let's say stateless, and then call this add page wrapper. Okay, and then what we need to do is to block of provide block if I need something, this one. Okay, and then we pass and pass locator from get it, and then we pass this user block. Okay, and then here we pass this one, that page. Okay, so what's the meaning of this block? We need to make sure block is available on this screen. That's why we have this issue. Okay, when we call this user block, we had that issue of saying, if I can find it on this, that this block is not recognized. Here we need to add it. Okay, could not find the correct provider of user block above block consumer. Okay, so this is how we do. Okay, so once you, because we use get it, it simplifies a lot of things for us, because otherwise we will need to add also here user dependency of user block, which was create use case. Okay, but because of locator we have already done that, and the locator, once we call, we run our app, it will do all those initialization for us. Okay, so what we need to, it was to say add page wrapper, and then we call this locator to make sure add page screen, it has information, it has information of user block. So if user block will be available for to interact with inside add page wrapper. Okay, and I think here we will call, when we go just going to call this one. Okay, so this is like the mother tree, and then all of those subtrees underneath it will have access to a user block. So that's how it's done. Okay, and mostly people are doing it on the main. They do that, but the downside of it is, once the application is so big, I don't think you have to interact a lot with main. So this is how you do it. Only you call only the required block that you need for all the necessary screens. Okay, so let's restart and see if the problem is still there, or it. Okay, and here we've read this. Go again. But state get it locator user remote source implementation. Did you accidentally, what's happening? Did I did something wrong? Okay, let's go to locator and figure out what's an issue. Okay, final get it. What is he saying? Where user report repo user remote source. But state user remote source implementation is not registered inside. Okay, so we need to figure out what's an issue. Just it was user. Is it the correct one? User remote source. Extend, so user remote source extend user remote source, which is this one. We will define it, abstract user remote source, and then locator is not registered inside. Did you, okay, did you accidentally say do get it SL is equal to get it dot instance instead of, no, we did the right way. Okay, so this is a problem of debugging. You have to figure out what's an issue. And here register this singleton, we call the type is type, and then here we call user remote source implementation. It requires I don't know, okay, so let's clear, let's close this up and run it again. Okay, of silly mistake I had to fix. I use remote source implementation. In user repository implementation, I was supposed to use user remote source, an abstract class, not an implementation class. Okay, so that's why we had an issue, because in injection here I used the user remote source implementation. So sorry for that, just have to fix it. Instead of using the implementation class, just use the abstract class of the user remote source implementation of the user remote source. Okay, so now let's test it. Okay, so and go to add page and see if it's working. Okay, so what I've done here, to save some time, I'm going to explain. Okay, so what's happening here in block consumer, we have listening capabilities and also builder. So we have listener and builder. Okay, so we can we can also use block listener, which what it does is just to listen for any state and do according to instruction. Okay, so but I usually like to use block consumer when I'm interacting with the button with a block or a qubit or any state. Okay, so here I can listen and also I can build. Okay, so here what I've done is on a listener I just check user. It's supposed to be user status, not use state status, but I don't want to change because I have to build it again. Okay, so for code generation to do its thing. Okay, but it's just a naming error. No, don't worry about it. Okay, so if you see in block here, we are checking on this. We are emitting this state, loading, created, and error if there's any issue. Okay, so we want also here to notify a user if there's anything happening. Okay, so if it's state user created, we can change that. Okay, but also we can put if there's an error. Okay, we can say any. You can say we get that from, I think, state dot state. I want to see an error. Okay, let's say else. If I want to see is an error, because I believe we're not getting that error. It's supposed to be, we are supposed to add an error here. Okay, but it's okay. I will do that on another functionality. But I was supposed to add that an error and here on user state, and then when it's coming from this catch, I will get it and show it to the user. Okay, we will do it on and deleting, updating. Okay, or fetching also. We'll see how do you notify the user if there's an error. Okay, so let's do this. Let's try it. Okay, so here just listen if the user is created, and then show a snack bar to notify user that you successfully created a user, because here when we call this create user use case, if it was successfully, we are not emitting this state of user status created. Okay, okay, so let's do it. Let's try it. Let's fill this form, username, call le, any name, le20, enter le at gmail.com. First name le, last name le, I don't know, McDonald, le McKinsey. Okay, don't worry about naming. Okay, so let's hit add button. Okay, so it's saying user created successfully. Okay, I think it's happening so fast. We can see a loading indicator, but no worries. We will see how to make sure we. Okay, so what we need to do? Let's go to Cloud Firestore on this project and refresh and see if we're having if there's any information submitted here. Okay. Okay, so we've seen that we have a user. Okay, this is called Ellie, as we So it's working fine. Okay, this is good, and it's a good progress. So now we can submit information to Cloud Firestore and we can see it here. This is good. Okay, so as you have seen, we've used blog to interact and emit a couple of state, and we've seen how to generate blog. We've seen how to use clean architecture to implement all of these necessary functionalities. We've seen how to get this information and submit them to the Cloud Firestore. Okay, so this is a good thing. It may be too much for now, but you can come and also repeat this tutorial until you've mastered it, because it's very good and it's very essential it's very also important to know this, because on large project, this is how they approach their task. Okay, you have to kind of have that mentality of single responsibility, so you can be able to maintain it and also manage it once it becomes so big. So all of that is because the application can be so big, so you have to make sure it's easy to maintain it, and also easy for a lot of developers to work on that same project. That's why the clean architecture it's a good way to write your app in a professional way. Okay, so let's go to see how do we retrieve all those information from Firestore and show them to our app. Okay,